Greetings, algebraites. Today we're going to be solving log and exponential equations. And everything we've worked up to today so far all that log information is going to provide us with background for this. So all the expanding we've done, all the condensing we've done, all the simplifying, all that's in order for us to solve equations like this. So let's look at this first problem here. So example number 1, we're told to solve this. We're on page number 1. And we are going to solve 27 to the 2x equals 9 to the x plus 2. So the key on this one is, notice the 27 and the 9. Both of them can be rewritten using a base of 3. Notice that 27 is 3 cubed, and 9 is 3 squared. Why is that important? Because if we can rewrite an equation to have the exact same base, 3's, then we can ignore the base and just look at the exponent. So I'm going to substitute in 27, and I'm going to put 3 cubed. And then I'm going to substitute in for 9, I'm going to put in 3 squared. Next, power of a power says when you have a power being raised to a power, we multiply the exponents. So this 2 here is going to distribute to the x plus 2, and this 3 times 2 is going to have a product. So here, now I get 3 to the 6x, and over here I get 3 to the 2x plus 2. Notice this 2 is distributing to both of those. Now, since we have bases exactly the same, we can ignore them. And as pointed out, this puppy here should be a 4. All right, so now you don't have to write this, but notice here, if I had a problem that said this, x over 4 equals 3 over 4, since you had the exact same denominator, oh look, I have a 4 here and a 4 here. That means the x and the 3 have to be the same. So effectively, I'm ignoring those and equating those. Same concept here, my bases are the same. So I'm going to equate simply the exponent, 2x plus 4. Now I'm going to subtract 2x from both sides, divide by 4 to get x equals 1. So to check, all we did was substitute in the 1 to the original problem. So I get 27 to the 2 times 1 equals 9 to the 1 plus 2. When I simplify that, 27 squared equals 9 cubed, question mark. And then when you calculate those out, 729 equals 729, and it does indeed work. All right, so we've checked that, and the key on this one that we just did was to equate the exponents. Can we get the same base? And once we have the same base, we can ignore the base. Well, sometimes it's not always that simple. Sometimes we're going to have to take the log of both sides. For in this case, clearly, I cannot simply write 21 to the power of 4, okay? It's complicated to do. So there is an answer, but there's no way that I could guess it. It would take way too many tries to guess. All right. So what do I do? If I can rewrite this equation into a log equation, or take the log of both sides. So notice what happens here. I can just do this. Essentially, I just write log 4 on both sides like that. Why? What happens? What happens? Well, I'll show you the next step here, and stuff will cancel out fairly well, is I do log small 4, big 4 to the x. Log 4, 21.
I thought the whole point of log was to get rid of the x up there.
Exactly. Oh, it will. Watch. what happens, so the question was, I thought the point of log was to get the x by itself, which it does. What happens to the log and the 4? They drop out. So I have x by itself.
Why do they drop out?
Log 4, 21.
Wouldn't they cancel out with each other, the log 4?
And the 21?
No, just log 4 is on both sides.
Not on both sides, but, I mean, they can on both sides, but that's not the function of this one. Now, change of base formula says I put the 21 in the numerator, and I put the 4 in the denominator. And now you plug that into your calculator to get a value. And I get approximately 2.196. So what steps did I do? I took, from the original problem, I took log base 4 of both sides. Notice that is technically the same thing as rewriting this expression as log 4 of 21 equals x. Just rewriting it into log. Rewrite into log or take log of both sides. Now, change of base formula in order to isolate x and calculate x. Now I'm going to use a calculator to just plug those in. So the solution is about 2.196. Like this. And we can plug that into your calculator. 4 to the 2.196 should be 21. So go ahead and check that. All right, the last one for today that we will look at is also taking log of both sides, but sometimes we can't do it on the offset. We can't just jump and say, let's log everything. Why? Because this here is being raised to an exponent, but the 2 here is not being raised to an exponent. Okay. It's tempting to just jump here and just log things. But I had this plus 2. So the key thing here is that I actually have to subtract 2 from both sides. Why am I doing that? Because I want to isolate the base, the power, in order to logify things. So the right side becomes a 4. Now, I can take the log 3. So what did I do? I subtracted 2 from both sides. And now, either you rewrite it with the log base 3 of 4 equals all that, or you just say log 3 of both sides. So that's going to look like this. Log with the base of 3 of 4 is equal to the exponent there, 5x minus 2. Now we say,
When do you post this video?
after class.
Why?
Okay. Okay, notice that this right here can be change of baseified, which I'll do in a moment. And notice that this, I'm trying to isolate the x, right? So I'm going to add 2 to both sides, add 2. But notice I'm going to do the change of base right here, log 4, over log 3, plus the 2, all equals 5x. Now, just to give you, it's probably easier at this stage to calculate this real quick, okay? So let's do log 4 over log 3 to find out that decimal.
These lines aren't helping.
Here, I did change of base formula to get 1.262. The plus 2 stays plus 2. You could add those together now, that's fine. And notice over here, I have to divide by 5 or multiply by 1/5. That's what's over here. Multiply each side by 1/5, which is the same as dividing by 5. So, in my calculator, I now say 3.262 divided by 5. 3.262 divided by 5. Approximately 0.652. Now, let's see what that means. When I take 0.652 here, that's going to be 3 to some power plus 2 is going to be 6. So notice this is going to be less than a 2 Because I can't say 9 plus 2 is going to be 6. All right.